All right, let's go.
Number 9. The planetary defense system itself. Before the objects, the machine that watches them. You cannot talk about dangerous objects without first understanding how we find them. Every potentially hazardous object is defined by 2 criteria. It must be larger than 140 meters, and its orbit must bring it within 7.5 million kilometers of Earth's path around the Sun. Any object meeting both criteria gets classified, gets tracked, gets a file. The tracking network is run by NASA's Planetary Defense Coordination Office. Data flows from the Catalina Sky Survey in Arizona, the Pan-STARRS system in Hawaii, and the Atlas network with telescopes across Hawaii, Chile, and South Africa. Every observation feeds into the Minor Planet Center at Harvard. Every new data point gets fed into computational models at JPL's Center for Near-Earth Object Studies. The models calculate where each object will be, not just next year, centuries from now. As of June 2026, the Vera Rubin Observatory in Chile, which began full survey operations in 2025, is scanning the entire southern hemisphere every 4 nights. Its main survey camera has a field of view so wide it can image an area 40 times the size of the full moon in a single exposure. It is expected to double the number of known potentially hazardous asteroids within its first few years of operation. The catalog is about to get much longer. What they are looking for lives in specific zones of the solar system. Most of it is not where most people expect.
Number 8. Bennu, the one with a date in 2182. Bennu is currently at the top of NASA's Century Risk Table, the most carefully watched object in the solar system. It is 490 meters wide, roughly the height of the Empire State Building, and then some. Carbon-rich, dark, a rubble pile, not a single solid rock, but a loose aggregate of boulders and gravel held together primarily by gravity and a small amount of cohesive force between dust grains. It rotates once every 4.3 hours. Its surface is covered in boulders so large and so numerous that NASA's OSIRIS-REx spacecraft struggled to find a patch of ground flat enough to safely collect a sample from in 2020. The sample is already back on Earth, 121.6 grams of pristine, carbon-rich material from the early solar system, analyzed since the September 2023 return. It contains water-bearing clay minerals and organic compounds, the kind of chemistry that was raining onto early Earth 4 billion years ago. Bennu itself may be a fragment of exactly the type of object that seeded early Earth with the ingredients for life. It is also the object most likely to hit Earth in recorded human history. NASA calculates a 0.037%, roughly 1 in 2,700, that Bennu will strike Earth on September 24, 2182. That is 156 years from now. The probability sounds small, but for a known object of this size, it is the highest confirmed long-term probability of any asteroid on the list. An impact would release energy equivalent to 1,200 megatons of TNT, roughly 80,000 times the energy of the Hiroshima bomb. Regional devastation on the scale of a continent. The OSIRIS-APEX spacecraft, the renamed OSIRIS-REx after its Bennu sample return, is currently en route to asteroid Apophis. The data gathered on Bennu is helping scientists refine models for every other object on this list.
Number 7. Apophis, the one that will be visible from the ground in 2029. On April 13, 2029, residents across Europe, Africa, and parts of Asia will be able to step outside and watch an asteroid pass overhead with their naked eyes, moving visibly across the sky, fast enough to track in real time. Apophis is 370 meters across, named after the Egyptian god of chaos. When it was first discovered in 2004, preliminary calculations suggested a 2.7% chance of direct Earth impact on that same April 13th date. For a brief period, it reached a 4 on the Torino Scale, a scale that runs to 10. No object in recorded history has reached 4 before or since. The entire planetary defense community went on alert. Further observations ruled out the 2029 impact completely, then ruled out 2036, then ruled out 2068. Apophis will not hit Earth for at least the next 100 years. But April 13, 2029 is still extraordinary. It will pass Earth out a distance of approximately 32,000 kilometers. That's closer than the satellites in geostationary orbit at 36,000 kilometers. Earth's tidal forces will likely alter its orbit during the flyby. Its trajectory going forward will be different from its trajectory coming in. Earth's tidal forces will likely change its rotation rate and possibly trigger landslides on its surface. 2 spacecraft are already heading toward it. NASA's OSIRIS-APEX will arrive after the flyby to observe what Earth's gravity did. ESA's Ramses mission will arrive before the flyby and orbit Apophis through the close approach itself. No asteroid of this size has ever been studied in real time during a planetary gravitational interaction. 2029 is not a threat, it is an opportunity. Number 6. 2024 YR4. The city killer that briefly had a 3% chance of Earth impact. This one is recent, and it was the most alarming planetary defense event in living memory. On December 27, 2024, the Atlas telescope in Chile detected a new asteroid. By January 2025, automated impact monitoring systems had calculated something that made scientists pay very close attention. Asteroid 2024 YR4 had a 1.3% chance of striking Earth on December 22, 2032. Within days, that probability climbed to 3%, the highest impact probability ever calculated for a known asteroid of meaningful size. The impact corridor, the zone on Earth's surface where it could potentially hit, stretched from the equatorial Pacific across northern South America, the Atlantic Ocean, Nigeria, eastern Africa, the Arabian Peninsula, India, and Bangladesh, a band across some of the most densely populated regions on Earth. The object is 53 to 67 meters across, a city killer. An impact would not end civilization, but it would erase a major urban area with an explosion estimated at the equivalent of 500 Hiroshima bombs. Think of the Chelyabinsk event in 2013, a 20-meter rock that exploded over Russia and shattered windows across a city of 1 million people, injuring 1,500. Then scale it up significantly. James Webb Space Telescope observations in March 2025 refined the size and orbit. By February 2025, the Earth impact was ruled out, but the story did not end there. As the Earth impact probability dropped to 0, a new calculation emerged, a 4.3% chance of the asteroid hitting the Moon on December 22, 2032. If it hits the Moon, a 60-meter rock strikes at high velocity. The crater would be small by lunar standards, but studies have calculated that the impact could temporarily increase the micrometeoroid debris flux in low Earth orbit by up to 1,000 times above background levels over several days. Satellites, the International Space Station, every object in low Earth orbit would face a debris storm. As of June 2026, the probability of the lunar impact sits at approximately 1.7%. The asteroid is no longer observable until it returns to view. The uncertainty will not be resolved until it comes back into telescope range. Number 5. 1950 DA, the one held together by van der Waals forces, due in 2880. 1950 DA was first spotted on February 23, 1950 by astronomer Carl Wirtanen at Lick Observatory, then observed for 17 days, then lost for 50 years because the observation arc was too short to calculate a reliable orbit, then rediscovered on December 31, 2000, and found to be one of the most unusual objects in the solar system. It is 1.1 kilometers wide, large enough if it hits Earth to trigger global effects, climate disruption, agricultural collapse, the kind of impact that reshapes civilization rather than destroys a city. Its most remarkable feature is not its size, it is its rotation. 1950 DA rotates once every 2.12 hours. For a rubble pile asteroid, a loosely bound collection of rock and gravel held together by gravity, this is far too fast. At 2.12 hours, centrifugal force at its equator should exceed the gravitational force holding it together. It should be flying apart, flinging material off its surface continuously until it disintegrates. It is not disintegrating. A 2014 paper in Nature by Bennu and colleagues calculated the answer. 1950 DA is being held together by van der Waals forces, the same weak intermolecular forces that allow a gecko to walk on glass. Forces between the dust grains on its surface are providing just enough cohesive strength, on the order of 64 pascals, to prevent the asteroid from tearing itself apart at its own rotation rate. A rubble pile asteroid held together not by gravity, but by something resembling static cling. NASA's current calculations place its highest Earth impact probability on March 16, 2880, over 850 years from now. But 1950 DA is one of only a handful of objects large enough that if that probability ever rises above background levels, it triggers immediate escalation and monitoring priority. Number 4. Comet Swift-Tuttle, the single most dangerous object known to humanity. Everything discussed so far is measured in hundreds of meters or a kilometer. Comet Swift-Tuttle is different in kind, not degree. It is 26 kilometers across. Its nucleus alone is larger than the object that ended the Cretaceous period 66 million years ago. Scientists estimate the Chicxulub impactor was between 10 and 15 kilometers wide. Swift-Tuttle is almost certainly larger. It orbits the Sun once every 133 years. Every time it returns to the inner solar system, it crosses Earth's orbital path. It is, as astronomers describe it, the single most dangerous object known to humanity. Not the highest probability of hitting Earth in the near term, but the highest potential energy of impact of any tracked object. If it ever strikes Earth, the impact would release energy roughly 27 times greater than the Chicxulub event, the event that triggered a mass extinction and ended the reign of non-avian dinosaurs. It last passed through the inner solar system in 1992. Calculations for its 2126 return show a very close approach in August 30th, 3044. The closest approach is currently estimated at 0.011 AU, about 1.6 million kilometers, well within the potentially hazardous threshold. The orbital solution is not precise enough yet to rule out impact in that passage. 3044 is 1,018 years away. You probably know Swift-Tuttle by another name. Every August, the Earth passes through the debris trail it leaves behind on its orbit. The particles, from gravel-sized to dust, burn up in the atmosphere. We call them the Perseid meteor shower. The shooting stars of August are fragments of the most dangerous object in the solar system, burning up harmlessly overhead. Number 3. The Torino Scale and everything below it. 2,500 objects nobody talks about. Apophis, Bennu, 2024 YR4, 1950 DA, Swift-Tuttle. These are the names that make headlines. They are not the only things being watched. As of June 2026, there are 2,539 officially classified potentially hazardous asteroids. The vast majority of them sit at Torino Scale 0, effectively no risk within the next 100 years. But the Torino Scale is a 100-year window. The solar system operates on timescales far longer than a century. The Palermo scale, the more precise measure used by professional astronomers, rates objects against the background impact frequency for any asteroid of similar size. A Palermo rating of 0 means the object poses exactly the same risk as a random asteroid of comparable size. A positive Palermo rating means it poses above average risk. There are currently 21 objects on NASA's Sentry Risk Table that cannot be completely excluded as impact threats over the next century. Most of them are small, city-scale threats, not civilization-scale. Most of them will be eliminated from the list as their orbits are refined with more observations. Then there's the category nobody talks about, objects we have not found yet.
NASA estimates 90% of all near-Earth objects larger than 1 kilometer have been discovered. For objects between 140 meters and 1 kilometer, the city killer to regional devastation range, only about 40% have been found. Thousands of potentially hazardous asteroids in that size range are still undetected, moving through the solar system, currently unmapped. The Vera Rubin Observatory is expected to change this dramatically. Its survey is designed to find most of the undiscovered population within a decade. The NEO Surveyor, a space-based infrared telescope specifically designed for asteroid detection, is in development and expected to further accelerate the completion of the catalog. Every object found is an object that can be tracked. Every object tracked removes an unknown from the map of threats. The act of looking is itself a form of planetary defense.
Number 2. The Chelyabinsk Lesson. What happens when we do not see something coming? February 15, 2013. Chelyabinsk, Russia, a city of 1 million people. A 20-meter asteroid, entirely undetected, entirely untracked, entered the atmosphere at 19 kilometers per second and exploded at an altitude of approximately 30 kilometers with a released energy equivalent to 400 to 500 kilotons of TNT, 30 times the energy of the Hiroshima bomb. The airburst shockwave shattered windows across 6 Russian cities. 1,491 people were injured, mostly from broken glass. Roofs collapsed. The atmospheric pressure waves circled the globe twice, detectable by infrasound monitoring stations as far away as Antarctica. Nobody saw it coming, not because the detection systems failed, because it approached from the direction of the sun, a blind spot in every ground-based telescope network. Telescopes cannot look toward the sun. Objects approaching from that direction arrive without warning. This is exactly why the proposed Neomir Space Telescope, an ESA mission designed to orbit between Earth and the Sun at the L1 Lagrange point, is considered critical by the planetary defense community. Its position inside Earth's orbit would give it a direct view of the region ground telescopes cannot cover, the Sun approach corridor, the blind spot that let Chelyabinsk through undetected. Neomir is currently in development. It has not yet launched. Until it does, any object approaching from the direction of the sun arrives with 0 warning time. Number 1. DART and Hera. The test that proved we can do something about it. On September 26, 2022, NASA did something that had never been done before in human history. They intentionally crashed a spacecraft into an asteroid to change its orbit. The target was Dimorphos, a 160-meter moonlet orbiting the 780-meter asteroid Didymos. The DART spacecraft, 610 kilograms, hit Dimorphos at 6.1 kilometers per second. The impact released the equivalent of 3 tons of TNT. Before the impact, Dimorphos completed one orbit around Didymos every 11 hours and 55 minutes. After the impact, that period was reduced to 11 hours and 22 minutes, a change of 33 minutes, more than twice what mission planners had hoped for as a minimum success threshold. The kinetic impactor technique works, not just theoretically, in practice, on a real asteroid. ESA's Hera spacecraft launched in October 2024 and is now en route to Dimorphos. It will arrive in late 2026 and study the aftermath of the DART impact in detail. The exact shape of the crater, the internal structure of Dimorphos, the cloud of boulders, some as large as houses that Hubble photographed drifting away from the asteroid in the months after impact. Hera will turn the grand-scale experiment into a fully characterized and repeatable technique. The data it returns will become the foundation for designing real deflection missions if a genuine threat is ever confirmed. From a 490-meter carbon-rich rubble pile with a 0.037% chance of striking Earth in 2182 to a 370-meter asteroid that will be visible with the naked eye in April 2029. From a city killer that briefly had a 3% Earth impact probability in January 2025 and may still hit the moon in 2032, to a 1.1-kilometer asteroid spinning so fast it should be flying apart, held together by the same forces that let a gecko walk on glass. From the largest tracked threat in the solar system at 26 kilometers, the source of the August Perseid meteor shower, to the 2,539 objects below the headlines being quietly cataloged every night. From the lesson of Chelyabinsk arriving undetected from the sun's direction, to the confirmed proof that a spacecraft can move an asteroid's orbit if we build one and launch it in time. Right now, 2,539 potentially hazardous objects are being tracked. Thousands more have not been found yet. The Vera Rubin Observatory is scanning. The DART data is being analyzed. Neo-Mir is being designed. Hera is approaching Dimorphos. The solar system has been throwing rocks at Earth for 4.5 billion years. For the first time in that history, we are watching. And for the first time, we have proved we can move them. Subscribe to Cosmic Hives. See you in the next one.